So 8.2 is about properties of parallelograms, and a parallelogram is just a quadrilateral, so four-sided figure, in which both pairs of the opposite sides are parallel. But there's also some other characteristics that are always true about parallelograms, and we're going to go through and prove these, but the things are both pairs of opposite angles are congruent, so angle A and C are congruent, and angle D and angle B are congruent. Consecutive interior angles are supplementary. So if I add up A and D, I'll get 180 degrees, or D and C, I'll get 180 degrees. Any two consecutive interior angles will add up to 180. Both pairs of opposite sides are congruent. So AD is congruent to BC, and AB is congruent to DC. And it's diagonal, so just change the color real quick. If I drew both diagonals, one from there to there, and one from there to there, they cut each other in half. So that's cut in half, and that's cut in half. So that point where they intersect will be the midpoint of both of the diagonals. So we're going to go through, we're going to prove that and apply it a little bit. So first thing, you're given parallelogram ABCD, and notice that they give that little symbol that just means parallelogram. They want you to prove that angle A is congruent to angle C. And just for this, just to make it easier, I just labeled this angle A instead of making it, angle BAD or something like that, just to make it simple. Okay? So the first thing we know is, so since it's a parallelogram, we know that AD is parallel to BC, so 1. We know that AD is parallel to BC, and we also know that AB is parallel to DC. So AB is parallel to DC. And that's because that's the definition of a parallelogram, and I'll just use the little symbol they use. Okay, so now 2. If those are all parallel, then I can think of this as a transversal, right? I could think of AB as a transversal, and so I know that angle A is congruent to angle 1 because those are alternate interior angles. So 2, angle A is congruent, and I should say the measure, so the measure of angle 1, and those are alternate interior angles. Okay, and then next I know that angle 1 is congruent to angle 2 because those are vertical angles, so we'll put that here. So 3, angle 1 is congruent. I can write it as congruent, that's fine. It's congruent to angle 2 because those are vertical angles. And then next we'll hop on over here. I know that angle 2 is congruent to angle C because those are alternate interior angles, just we have a different transversal now. So now I know 4, angle 2 is congruent to angle C, and because those are also alternate interior angles. And then so finally, if we look at what we started with, we started by looking at A, and we said A is congruent to 1, which is congruent to 2, which is 1 is congruent to 2, which is congruent to C. So we know that A and C are congruent. So angle A is congruent to angle C, and that's just the transitive property. So we linked them all the way around. Okay? So notice you could use the same idea to prove that D and B are congruent. You just work with D and work your way over to B using exactly the same logic. Okay, second thing, it says prove that A and D are supplementary. So let's see if I have another color here. Not really. So I have A and D, and what they want to know is that they add up to 180, and that's actually really easy if you remember that any consecutive, remember we could think of this as the transversal now, any same side or consecutive interior angles are supplementary, so that's really easy. So we already know this. Angle A plus the measure of angle A plus the measure of angle D equals 180 degrees, and the reason is because same side or consecutive interior angles are supplementary. Okay, so we proved that any pair of opposite angles, interior angles, are congruent, and that any consecutive interior angles are supplementary. So I could have looked at A and D like I did, or I could have said D and C, either way. All right, next it says prove that AD, this segment right here, is congruent to BC. So prove that those are the same length, okay? And to do this, I'm going to draw AC, and I'm going to label some of the angles. Okay, so the first thing I'm going to do is I'm just going to write 1, right? We know that AC is parallel to BC, and AB is parallel to DC. So we'll just write that real quick, and that's because that's the definition of parallelogram, same as before. So AB is parallel to DC, and I could do AD is parallel to BC, and that's just definition of a parallelogram. Okay, 2, I drew AC. So drew, or draw, I should have just said draw AC, and that's because between any 2 points there exists one line. So between any 2 points exists one line. All right, so now what we're going to do, you might already be thinking this, we're going to prove the triangles are congruent. And once we prove the triangles are congruent, we can prove that any of their corresponding parts are congruent. And the way we're going to prove the triangles are congruent is by just looking at the angles. So the same thing we just did, if I think of the line I just drew as my transversal, then I know that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, because both sets are alternate interior angles. So I can say 3. I can say angle 1 is congruent to angle 4, and angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, because they are alternate interior angles. Okay? And then the last thing we need to do is we can just say that AC is congruent to itself with the reflexive property. So 4 AC, segment AC is congruent to segment AC. That's just reflexive property. And then so if you notice, we already have enough to prove that the 2 triangles are congruent, because we have angle, side, angle. So let's just write that. So we're up to 5. So triangle ADC is congruent to triangle, what matches up with A? C, B, A. And because of angle, side, angle. And now, once you prove the triangles are congruent, you know that all of the corresponding parts are congruent, and one of those corresponding sets of parts is AD and BC, and so we can write our last step, which is AC, or AD, we can write, is congruent to BC, which is what we wanted to do, and that's because corresponding parts of congruent triangles are congruent. Okay, and you can use exactly the same steps to prove that AB is congruent to DC, and in that way you can show that all pairs of opposite sides are congruent.